so let's take a look at what we're starting with here in 2.6. And I think you will be very happy to notice that look, a lot of this we've already talked about. Okay, so let's take a look at it and see what I'm talking about. We have a rational function, and we are going to sketch it. But in order to sketch it, we are going to list its x-intercepts, its y-intercepts. All right, I'll write out the word for the first time. From now on, I will abbreviate this. I'll write this out every time. The horizontal asymptote, the vertical asymptote, and any holes that it might have. So that vocabulary should sound familiar to you. We talked about that before. Do you remember talking about holes and asymptotes and all that before? Why, yes, Mrs. Ford, I do remember that. Okay. So, anybody remember anything about it? So, like, here's my problem. This is actually quite an easy problem. We're starting kind of easy. I'm going to jump in and say there are no holes in this problem. How do I know right away? Josh?
Something because it
doesn't factor and cancel. Remember, how do you get holes? Think back.
By canceling.
You have to cancel something out. And in this problem, nothing cancels. Remember, sometimes we have bigger problems and we factor it and those things go away. That's how you get a hole. That's the only way to get a hole. So since that didn't happen, I know I don't have any holes. All right, anybody remember anything about asymptotes?
Isn't the horizontal axis?
No, I don't know what you mean by the axis. To get the horizontal, we box these in. Is that what you meant?
Yeah.
Yep, that's how we get the horizontal asymptote. So what would my horizontal asymptote be? Y equals 1. So I'm going to make a little note over here. I would do the same if I were you to help me remember. I'm just going to say box in the x's, but you explain it any way it makes sense to you. That's how you get the horizontal asymptote right here. So in my picture, I'm going to go ahead and draw my horizontal asymptote at y equals 1. Perfect. Okay, anybody remember anything about a vertical asymptote?
Oh, well.
No one remembers? Vertical asymptotes are cannot be's. In this problem, x cannot be 3. Vertical asymptotes come when the denominator equals 0. Because we all know the denominator can never equal 0. So whatever you want for x is fine, but it can't be 3. And when it can't be something, that is a vertical asymptote. That is a complete break in your picture. Now, the intercepts we didn't talk so much about, but you've talked about them many times before. What do we mean by intercept? When we say x-intercept, what does that mean? What are we talking about?
Where it hits on the
Where
graph
it hits on the x-axis, exactly. And x-intercepts come from your numerator equal to 0. X-intercepts come from your numerator. So what makes the numerator 0? What could I put in here and get 0? Negative 2. So my x-intercept is negative 2. That is my x-intercept. And then What about my y-intercept? How do I find my y-intercept? I let x be 0. And what happens if I let x be 0? What do I get? People put 0 in. Negative 2/3, yeah. Now, as soon as you have answered all of these questions, and put all that in your graph, you're actually ready to sketch it now. I want you to think back to your BFFs. Do you remember the reciprocal function? The reciprocal function was the one written as a fraction. Remember that? Anybody remember what it looked like? What did the reciprocal function look like? This is where you guys need to bring in your cans, because all this is on your semester exam, and the cans are extra credit on the semester exam. So the reciprocal function is the one that looks like this. It has an asymptote, and two curves like this. This is going to be a version of that. It looks a little different, but it's the same idea. It's a fraction. Only the asymptotes have been moved now, but the curve is the same. Does that make sense to you, given those 2 points that I plotted, that I would have an arc that looks like that? Mm-hmm. And then the other arc is going to be opposite it up here in this corner. So it's going to have that shape. It's just moved a little bit because of these numbers right here.
How did you find the x-intercept?
Let the numerator be 0. The numerator.
Wouldn't that equal positive 2 then?
Is 2 plus 2 0? I'm not letting x be 0. I'm saying what makes it equal 0.
Oh.
What makes the numerator equal 0?
Okay.
All right, let's try the next one. I'll leave all this stuff here because this is the stuff we have to find every time we sketch. In a couple days, we'll be having a sketching quiz where I will give you a problem like this, and you will have to do all of this by yourself.
Are they all gonna be reciprocal?
They're all rational functions, yeah. But they're gonna get a little more complicated, you'll see as we go. But here's another kind of easy one. And I say easy because do I have any factoring to do?
No.
That means there won't be any canceling, which means there won't be any oops. All right, so these are the things you gotta remember. These are the things you have to remember. This is how you find this stuff. So, we'll start with the x-intercept. What makes the numerator 0? What number could I put in there and get 0? 2. So my x-intercept is the point 2, 0. And by the way, every time I graph something, do I label my key points? Yes. Have I asked you to do that? Yes. It absolutely floored me yesterday. Most of you did really well on your test, so I'm very pleased. But you're missing dumb stuff like not labeling your points. Make sure you label them. Here too, you're gonna have to label them here. All right, how about a y-intercept? What happens if I let x equal 0? If I let x equal 0, I get -2. Don't look at me like deer in headlights, folks. Put a 0 here and a 0 here and figure out what it equals. And that is your y-intercept. All right, box in my x's. Now be careful on this one. When I box them in,
On this interruption, Cathedral. I need members of the Cathedral Boys basketball team that have been coming to the morning workouts to please come to the chapel. If you've been coming to the boys basketball workouts in the morning, please come to the chapel. Thank you.
I hope everything's okay. Box these in. What do I get when I box those in? -1. So my horizontal asymptote is at y equals -1. Okay, vertical asymptote. What makes the denominator 0? 1. So I have a vertical asymptote at x equals 1. And I'm done, because there isn't, or aren't any holes, right? Let's look at our points. Can you figure out what it looks like? Remember, it's those two arcs, so what's it gonna look like?
Be right there.
There's one gonna be right here, there's gonna be one right there, there's one of your arcs. So it's gotta contain that point, right? And then the other one is right here. It has to go through the points. And it's framed by the asymptotes, okay? So the asymptotes are like containing it in there. It has to go through those 2 points. Alright? Alright, now we're ready to proceed, which is a little bit bigger problem. But we're going to do everything exactly the same way. Alright, so here we go. What do you think we ought to do before we start this guy? Factor, always. We talked about that before. It's always a good idea to factor your problem. So how does the top factor?
X plus 2.
Plus 2 minus 2. It's the difference of squares. And then the bottom is plus 3 minus 3, also the difference of squares. And we factored, but nothing canceled, so I'm trying to write the word none, and it's not coming out very well. There are no holes. Would everybody agree with that? Even though it factors, there aren't any holes. Okay. Well, what do we have? Tell me. You come up with some stuff. I don't care what order, no matter what order we do it in. Find something.
Would the horizontal be 1?
The horizontal asymptote is y equals 1. She looked at her problem and said right here, y equals 1. Very good. That's my horizontal asymptote. Perfect.
How do we do that on the vert with, will we do both of them 0 for the denominator? So it'd be 0.
What's 0?
Would it be, because if you put in 0 for both the x's, then it'd be just 0, because you get plus 3 and then minus 3.
But you're multiplying. Those are factors. Those are being multiplied. So are you trying to find the x-intercept, or y-intercepts, I mean, is that what you're doing?
No, I was trying to do the vertical one where the denominator equals 0.
So what makes the denominator 0? Either -3 or
Positive 3.
+3. They're both vertical asymptotes. Anything that makes the denominator 0 is going to be a vertical asymptote. And since there are 2 numbers that make the denominator 0, if you put a -3 in, you get a 0. If you put a +3 in, you get a 0. They are both vertical asymptotes. So this picture is going to look different now. So it's going to look different, and that's okay. All right, what else do I know?
What's that?
1 and
what makes the, numerator 0? What numbers would make the numerator 0?
Positive 2 and negative 2.
-2 and +2. So there's 2 x-intercepts, that's fine too. I told you, the pictures are gonna get a little more complicated, but this is how you find what you need. Doesn't matter how complicated the picture is. How about y-intercept? What happens when I let x be 0? It's easiest to do it right here. If you put in zeros, what do you end up with? 4/9. Which is less than 1, so it's underneath that asymptote. Wow. That's it for important stuff. Anybody have any idea what's going on between the asymptotes here? What do you think? You got those 2 points. What do you think is happening there? It's like yes, Leslie, that's exactly right. It's a parabola-like thing. You got a parabola-like thing in there. Now, any idea, you don't have any points to go with, help you go on, but any idea what's happening to the right and left of the picture? You got the center taken care of. Any thoughts on the right or the left?
Can we just let it be?
No, there's picture out there. There's picture.
Would we shade it or something?
No. So here's what you can do. You can always plot more points. So these are the important things. These are the things that you're gonna get asked for, and are gonna get graded. If you can't figure out what your picture looks like, then you can set up a T-chart and plot some more points. So maybe plug in 4 and see what happens. What do I get when I plug in 4? What do I get when I plug in 5? -4, -5. You don't really need to do that though if you have some common sense. If you're thinking about it, you don't need to do it. Over here on this side of the picture, this is an asymptote and this is an asymptote. What did I tell you about the asymptotes? What do? They frame your picture. Okay? They're the guidelines for your picture. So over here, my picture either has to look like that. It can't look like anything else. There's no other option. Anything you think of will be wrong because the asymptotes have to frame it. So it can't be like this. It's not gonna look like that. It has to follow the asymptotes. But it could follow the asymptotes on the bottom. But I know it can't be the bottom one. It has to be either this or this. How do I know it cannot possibly be the bottom one? Who can tell me?
Because it's positive.
No? See that right there? What would that be? That's an x-intercept, right? Have I already plotted my x-intercepts? And as soon as I plotted my x-intercepts, that means I can't cross anywhere else. Do you see what I'm saying? So I have 2 choices. It either arcs like this, or it arcs like this. That's what they look like. That's what they have to do. It cannot be this one because it cannot cross the x-axis. So over here I have the same dilemma. It's either like this, or it's like this. Well, can it be this bottom one?
No.
Because look what happens right here. I have to cross. And these are the only 2 points where I can cross. So it can't be this one, it has to be that one.
What if your horizontal asymptote is on the origin so that it won't cross the x either way? How do you decide then?
Oh, if the asymptote happens to be the origin,
Yeah.
well then you're gonna have to use some other points and figure that out. So if so his question is, what if the asymptote were on the x-axis? Then clearly it could be this arc or this arc, either one. So I would probably pick one point, plug it in, and if it's positive, it's up here, and if it's negative, it's down here.
And you plug it in as X.
You plug it into your x value, yep. All right, they're going to get trickier, guys. You really, really, really have to be paying attention and thinking. All right, let's see what's next. It's always okay to set up a T-chart. The other day I was graphing something and I was a little bit perplexed, so I just plotted some points. And that helped me figure it out. All right, here we go. Step one, what do you think?
Factor.
Factor, all right. I'm gonna go this way with my factoring, so let's see, what do I have on the top? X minus 5, x plus 1, okay, that looks good. By the way, it's gonna be really, really important that you factor correctly. So how can I check this if I'm not sure? Boil it back together, right? Just boil it back together. Double check. All right, how about, what's going on the bottom?
Take out a 2.
Take out a 2 first. And keep the 2. The 2 stays part of it. But now we can factor that into x plus 2, x minus 2. Oh shoot, I was thinking we'd get a whole out of this one, but we're not going to, are we? Okay. All right, so no holes, we got that figured out. All right, tell me what we do have.
When we're doing the horizontal, do we include the 2 with the X?
Yes, absolutely. Right here, right here. So what's your horizontal asymptote?
1 over 2.
1 over 2, so horizontal is y equals 1/2.
So you always go to the original to find that?
You don't have to, but it's easier because these x's are all split up. So it's always easier to look there, but it won't matter. It doesn't matter. Okay, what else do I have? The vertical asymptotes are at 2, x equals 2, and x equals negative 2. Because where do vertical asymptotes come from? The denominator equals 0. So if I put in a negative 2 and a positive 2, I would get a 0 down there. So those are my vertical asymptotes. Okay, what else?
X plus B plus 5, negative 1.
So I got negative 1 and 2, 3, 4, 5. Those are my x-intercepts. They come from the numerator. Okay, perfect. We're all done with this stuff except y-intercept. What's my y-intercept? That's another one. It's easiest to go back to the beginning, because if you put zeros in for all the x's, if every x becomes a 0, what do you have left? Negative 5 over negative 8 is all that's left, right? So it's 5/8, which is bigger than a half. Now, kids, how do you find a y-intercept? You let x be 0. I don't care where you let x be 0. If you put zeros in here, that's totally fine. Somewhere you let x be 0. Josh?
When you're plugging stuff in, is does that go for like any step in it at all? It doesn't
Yes.
matter which equation you're
Yes.
doing it in?
The only time it matters is with a hole. With a hole, you have to plug whatever
The
you
one that's-
canceled
that-
into the new
yeah,
one, yeah.
yeah.
But otherwise, no, it doesn't matter.
Alright.
Would it still be a parabola because they're squared on the original problem?
Okay, so I'm not, yet. Oh, I am not here, so you're saying there's a parabola in there?
Well, I'm saying, would it be because of the, like, we factored it out, but
Mhm.
on the original one, they're squared. So,
Well, I don't know, let's see. Am I going to get a parabola shape out of this? I want you to think about it. I think Jack is looking in between the asymptotes here. These two dots have to be connected. Do you think they're connected with a parabola type shape?
No,
Why not?
it's like a whole different shape.
Why can't they be? They cannot be a parabola. Why not?
So they could cross
If
the
they were a
asymptote.
parabola, what would happen right here?
there would be a point.
There'd be a point there, and there isn't a point there. So shoot, these have to be connected. So that part is exactly right, they have to be connected. But what does it do after it hits right there? Well, it doesn't stop,
It's going straight
it
up.
just keeps going up. So what shape do we have in there?
Oh, what's it called?
Is it the cubed one?
It's like a cubing shape. Now, this isn't a cube problem, that is not a cube curve, but it has that shape. It has to, because you said it has two choices. It comes back down, or it keeps going up. And it can't come back down because there's no intercept there, so it has to keep going up. All right, now, what's happening to the left and the right here?
With so the right side would be the bottom curve.
So, did you hear what he said? He said, Miss Ford, don't forget, we got this point out here. And since we have that point out there, don't we have to have our arc like that? Doesn't our arc have to be down there? What about on this side? Where's the arc on this side? Leslie's pointing up, and she's right. Why does it have to be up here? Because there's no point out here to cross through it. I'm telling you, they get weird looking. All right, onward and upward, here we go. Okay, here we go. What do you think? We're gonna always factor first. So here we go. The top doesn't factor, obviously. What about the bottom? Plus 1 minus 3?
Still doesn't.
Still doesn't cancel, does it?
Hey, dude, about to go.
Crazy. All right, everybody okay with that factoring? We don't just guess at our factoring. Well, we actually do just guess at our factoring, but then we don't move on until we have checked it, right? Make sure it's right, okay. All right, tell me what I have then. No holes, as Josh pointed out. The horizontal asymptote actually is not 1. Why not? This is a tricky one, but we talked about these before.
Because it's not the same.
X
The
squared
powers
is
aren't
not
the same. Remember that from before?
You have to like add.
So I want to compare x squared, but I don't have an x squared on the top. So I put 1 up there, but it has to be 0. So where's my horizontal asymptote? 0. Y equals 0. remember, you always compare, when you box in, you always compare the highest powers. So the highest power is x squared. Wherever you're missing one, you put in a 0. I don't have one on the top, so it's 0 over 1. 0 over 1 is 0.
X-intercept's -5.
The x-intercept is going to be -5. Yep, there's only one of them because they come from the numerator. Okay. Vertical asymptote, there's 2 of them, -1 and 3. Is everybody okay with that? Okay, all I need is my y-intercept. How do I find my y-intercept? Let x be 0, wherever you want to do it, let x be 0.
We made last year. Or, no,
So
It'd be 5 over -3, wouldn't it?
Yeah.
So -5/3. Which is -1 2/3.
What's the abbreviation for asymptote?
This one is crazy.
it's great, there's nothing.
So one thing I know for sure. I know for sure that in the middle here, I've got some kind of shape like this. I know that for sure. How do I know that for sure? Remember, I have this point, okay? I have that point. Can it cross in here? Are there any intercepts in there? No. So doesn't this mean everything has to be down here? So I got something that looks like that. I have no idea, truly, no idea what the rest of this looks like. So I'm gonna come over here. I know this is what Wyatt was talking about before. It either does this or it does this. You have to agree with me on that. There's nothing else it can look like. It's this arc or it's this arc. So I'm gonna take, that's 3, I'm gonna take 4, and I'm gonna put 4 into my equation. Now you can put it in here or here, it doesn't matter.
Where did you get 4 from?
I'm gonna plot a point to the left of, or to the right of 3. I'm using 4, you can use 5, I don't care. I gotta know if this arc is positive or negative. And the only way to tell is to test a point. So I'm testing 4. So if I put 4 in, I get 9 over 4 plus 1 is 5. 4 minus 3 is 1. I don't even care what number that is. Is it positive or negative?
Positive.
Positive. That means my arc is on the positive side. You see how I figured that out? I have nothing to go on, no points out there, so I made one. I made a point, and as soon as I figured it out that it was positive, I knew it was up there.
Is it because of the asymptotes that you know how to graph the 0?
Yes.
Negative side of, like, how did you know to do the, like, arch?
Where?
Like, at the 0.
Here?
Yeah.
Okay, what do you want to put there? Tell me what shape you want to put there.
Like, well, like,
Okay, no, stop. Tell me what shape you want to put there.
I guess that. But,
Well, I mean, I'll tell you why it can't be whatever shape you want, but I need to know what you're thinking.
I wasn't thinking of it.
Okay. Then you're thinking the right shape. That's it. It can't cross this line.
So it doesn't need 3 points to make that.
fact that it's below the x-axis, it's negative, everything's gotta be negative, because this is positive, and it can't cross, because there's no points in there. Same thing over here, it's either all negative, or it's all positive, because it can't cross. Now, this one's tricky, because could this picture go like this? Yeah. Could it also go like this though? Yeah. So I gotta figure out whether, let's say, -2 gives me a positive or a negative answer. So again, you plug -2 in wherever you want. I'm gonna put it in here. -2 plus 5 is 3. -2 plus 1 is -1. -2 minus 3 is -5. So when I put in -2, this is what I come out with. Is that positive or negative? That's really all I care about. That's positive. So -2 gave me a positive, so it looks like that, not like this. Now, out here, what in the heck is going on? It doesn't stop. Your picture's gonna go on forever in both directions, always, okay? All your rational functions. So I'm gonna try one more point, -6. You can try anything you want. Left is -5. I'm gonna try -6. -6 gives me -1 over -5 times -9. Yeah, -6 in, because I'm trying to figure out how to continue this line. Am I gonna continue it underneath, or am I gonna continue it above? So, tell me about that. Positive or negative? Negative. So that means I'm gonna continue it underneath and follow my asymptote out that way. Now, don't shoot it down. That's your temptation, is to shoot it down. Don't, remember, it has to follow its guideline. It has to follow its asymptote. But I had to figure out if it followed it on the top or the bottom.
So where'd you get the 3 and the -1 and -5?
I put in 4, or no, I put in -2. I put in -2. So -2 plus 5 is 3. I have to pick points in these various regions to figure out if I'm on top or bottom. So I was checking -2 to find out if my picture went up or if my picture went down.
Will it, like, typically almost always, when you have 3 asymptotes, have like 2 of them on the top and then like 1 on the bottom, or like flipped? Or is that just a
No,
coincidence?
because we just did one where we had 1 on the top, 1 on the bottom, and a squiggly in the middle.
Okay.
We just did an example like that, so no, there is no typical behavior. Other than on the sides of the picture, the outsides of the picture, you're gonna have an arc and an arc. But who knows, you know, how they're situated, but you will have that shape on the ends of the picture. All right, one more. Here we go, last one. Oh, no, we have 2 more. So we're gonna get 1 done, so let's do F right now. We'll do 1. All right, so what am I gonna do first? I'm going to factor, and the bottom factors easily into the difference of squares. And how does the top factor? -4 plus 1, let's double check that, make sure it's right. Because if you mess up your factoring, you are up the creek without the paddle, folks. All right, we gotta have the factoring right. Oh, why, Josh?
What's up?
What do you notice?
We're back there, we're canceling.
We're gonna cancel. So we're gonna end up with just x minus 4 over x minus 1. Would
So
everybody
what's
agree
our
with
hole?
that? So that means we're gonna have a hole this time. What X value canceled out? Negative one. Negative one. So we're gonna let X be negative one. And then we'll come back here. It matters now. It matters. This is where you gotta plug in. So you plug in negative one right here, and what do we get? Negative 5 over negative 2, which is positive 5/2. So we come over to our picture, and at that point, negative 1, positive. Negative 1, positive 5.5, 5/2, 2.5. I put a hole, open dot in my picture. Kids, we did that already. We talked about that earlier, remember that? Where's some other stuff? Let's fill in the rest. Look at this right here.
Negative 4 is that x-intercept.
Positive 4
Or positive.
is my x-intercept, because that's what makes the numerator equal 0. If you're positive 4, you get 0. My horizontal asymptote is 1, y equals 1. Where's my vertical asymptote? At 1, x equals 1. Where's my y-intercept?
Positive 4 and yeah, positive 4 and positive 1. No.
So it's just 4.
4. You put in 0, it's negative 4 over negative 1. Just put 0. 0 minus 4, 0 minus 1. Figure that out. So 0, 4 is up here. That's 1, 2, 3. Josh?
You see like where the 4, 0 is?
Mhm.
This is like a crazy guess. But you're not gonna make the normal shape?
You are gonna make the
You
normal
are?
shape.
Oh, then you make it from.
It's gonna look just like this, yeah. It's gonna be your little arc right down there.
So like what tells you to like make it go like down the last one? You know what I'm saying?
Because if the asymptote was on the axis.
Oh, okay.
Here, the asymptote's up here. It's gonna approach its asymptote,
Okay.
okay?
Wait, I forget with the hole, can it not go through it?
No, it does go through the hole. I mean, it like skips over it.
Oh, yeah.
But the hole is part of the, it's connected. It's just like a gap in there. It skipped over there. But yeah, the hole is part of the arc. This problem, look back at our very first example. Our very first example looked kind of like this, didn't it? This is exactly the same picture, except it has a hole in it. There's nothing tricky or fancy about this because it's basically just this. Okay? All right. So what will happen now is next time, we'll finish our notes and practice for a quiz, and then depending on our quiz, will either be the next time or the time after that. Tomorrow we have shortened periods. I'm not exactly sure how all that's gonna go. So we'll